I made this cool airlift bag to help me put in and take out my aluminum boat dock without breaking my back. The bag's constructed with a TPU-coated nylon fabric that's been heat welded together using a small handheld iron that I modified specifically for this purpose. My plan is to strap the bag to my dock sections and inflate or deflate on demand, allowing me to manipulate the floating dock section with ease. As you join me for this in-depth build, please consider hitting that like button and subscribing. It really helps the channel and it allows me to make more cool videos like this. This is 840 denier TPU-coated nylon. It's some pretty thick stuff, clocking in at about 0.5 millimeter. The TPU coating is on the shiny side, and you're able to heat weld it to another piece of fabric when you face the TPU sides towards each other. I was unable to find anything this thick in the US, so I ordered 11 yards of this 57-inch wide fabric from AdventureExpert.com, which is based in Slovenia. The fabric only took about 8 days to get to me, which is pretty great. I'm going to make a bag that's about 60 inches long by measuring out that much fabric and then cutting it in half lengthwise to create each side of the lift bag. That'll be about 29 inches wide. It's important to note that the TPU-coated sides must face each other to be heat weldable. I made a little template to help me cut out some retaining loops that will sort of look like handles. This will allow straps to be held in place around the bag when I secure it to my dock section. I designed this so the body of the handle would be reinforced by folding the sides around onto itself and welding it into place. I have my iron set to 170 degrees Celsius, and with a little help from Mrs. Builds, I spot welded things into place before going to town on the rest of it. There's definitely some learning curve to getting good welds. I'd highly recommend practicing or starting on non-critical parts of a build before moving on to the serious parts. It also took me a bit of time to dial in the right temperature for my iron, as well as getting a feel for how long to hold it in place to get a good weld. The type and thickness of your material is also a factor here as well. You need to find the right temperature that allows heat to transfer through the nylon and melt the TPU on the other side, without melting the nylon itself. For me, 170 degrees Celsius seems pretty good, and holding it in place for about 15 or 16 seconds gives me a solid weld. Now that my handles are complete, I need to cut some holes so I can weld some patches of fabric underneath, which will expose the TPU side on the outside of the bag. This creates a TPU-coated surface that I can weld my handles to. Remember, you can only weld fabric together when the TPU sides are facing each other. After heating a spot for about 15 seconds, I apply pressure to the area with my green silicone roller to help set the weld. This looks fast in the video, but this part was pretty time consuming because there was a lot of area to cover and my iron can only heat a few inches at a time. A few times I slipped with the iron and accidentally touched the TPU coated surface. This left a mark and made me worried about creating a potential weak spot. For a little insurance, I cut some small pieces of fabric to weld on top of those mistakes. This isn't really a big deal because it's on the inside of the lift bag and no one will ever know that these little pieces are even there. Okay, now that all the rectangular holes are patched with TPU facing out, I can weld my handles down. I used a weight to hold the handle in place, and I also wedged some rulers under the center of the handle to make sure that it wasn't welded too tightly. Alright, all 4 handles are in place, and now let's work on the valves that will supply air to the bag. I ordered these TPU valves off AliExpress that should be compatible with my TPU coated fabric if I can figure out a way to hold it flat so I can make good contact with my iron. I decided to make a jig out of a piece of scrap wood by drilling it out with a 1 1/8 inch hole saw. Then off camera, I used a chisel to cut out a section for the barb that sticks out on the valve. Now I can drop the valve into the block of wood, and the outer flange makes nice flat contact around the edges. I cut out a donut-shaped piece of fabric that I will weld to the bottom of the valve. Before I do that, I wiped off the surfaces with alcohol to remove any potential contaminants. Welding this is a bit tricky because it's such a small area. I found it was easiest to use the flat spot towards the tip of the iron to heat things up. I took my time working around the edges and flipping the valve over to check my work. It's nice that the valve is clear because that made it easy to look through and inspect the fabric weld. I used a small paint mixing stick to bridge the gap under the flange where the barb sticks out. I also found this stick useful for protecting the fabric from the back of the iron in certain situations. Originally I was only going to use a single valve, but I decided to add a second one so that I have more options if there are any issues with how long it takes to inflate or deflate the bag. After measuring and marking the top of the bag, I carefully cut 2 holes for the valves to fit through. Then I pushed in the valves from the inside of the bag. Using my fancy wood jig again, I stabilized the valve and created a flat surface to work on. Then I welded my TPU donut to the inside of the bag. Note that all the materials used in this video will be included in the video description if you want to check any of that out. I repeated the same process for the second valve as well. Now that both valves are welded to the inside of the bag, I flipped it over and welded the top of the bag to the valves. Again, I used my wood stick to prevent from accidentally touching the material with the back of the iron. Of all the welds that I did on this project, I really took my time doing a good job on these valves. Okay, the big day has finally arrived where we can weld the two halves of the bag together to turn it into an actual bag. I used some painter's tape to hold the edges together because I was worried about things shifting during welding. I marked the edge with fabric chalk to help guide the iron placement. I really wanted to avoid a situation where the welds are uneven and have sharp edges that could focus pressure on a single point when the bag is inflated with air. Working my way around the edges was time consuming, but it was really easy compared to the more complex welds that I did previously. The handles that I welded a while back were definitely my least favorite part. If you're wondering what that red pad is that I've been welding on top of, it's just a sheet of silicone that I picked up on Amazon. I'll put a link in the description along with the other tools and materials that I used. Now that all the edges are sealed together, I need to work out how to inflate the bag. I bought some cheap rubber hose on AliExpress and picked up some valves and air fittings on Amazon to make an air distribution manifold. I also got this really cool low pressure gauge so I can hopefully avoid popping the bag that I worked so hard on. I'm still experimenting with how to set this up, but the gist is that I'll put a valve on the hose that goes to the airbag and attach a quick connect to it so that the hose can be detached from the manifold. I imagine eventually having multiple lift bags and being able to fill them from a central point, but then detach them to be able to still individually control when air is released from the bag. If you're interested in knowing more about the manifold, let me know in the comments. I'm going to feed the lift bag from a single hose for now, so because the bag has two barbs on it, I picked up these Y connectors that will let me supply the bag from a single hose. Possibly something that I might want to change in the future, but we'll have to wait and see. You might want to consider subscribing if you're interested in any potential updates. And if you've made it this far, maybe hit that like button. Okay, let's hook up the hoses to the bag. I initially bought this rechargeable pump that's designed for stand-up paddleboards, but the battery never worked in it, so I switched over to a wired air pump for now. I'm going to need to figure out something else to do this safely on the lake without having to use mains power by the water. The bag filled in just under 2 minutes, which was a lot faster than I imagined. I filled it to just about 0.75 psi. I'm also pretty surprised that there don't appear to be any leaks. The edge welds actually look pretty great, and I only found a few areas that look like I could touch them up a little, so I marked them with some fabric chalk. Here's the dedicated valve and quick connect that are attached to the bag's hose. Since there's no weight on top of the bag, the air will only drain a little bit on its own. I'll use the other side of the pump to speed up the deflation. Okay, now I'll hit the spots that I marked that look like they could use a little extra welding. This thing came out pretty awesome. Definitely exceeding my expectations for a first build attempt. The real test will be in the spring when I use the lift bag to put my dock in the water. If you're subscribed, hit that bell icon if you want to get notified when I post a new video. Alright, well I hope you thought this was cool, and I'll catch you in the next one.